presentation brought to you by StarWind Software. My name is Boule. I'm one of the senior solution engineers here with StarWind. And today we're going to be talking about high availability storage, specifically as it relates to the Iscuzzy realm here, and really sort of breaking the presentation up into a couple of different parts as I take you through the quick agenda here. So the first half of the presentation is going to be mainly PowerPoint driven. We're going to do a quick overview of SAN technology. We're going to talk a little bit about SAN versus direct attached storage, and talk about some of the benefits of SAN outside of some of the buzzwords that you hear out there in terms of being able to unlock high availability features within a resource cluster for your virtualization environment. Some of the fundamentals that are associated with sort of a more centralized management of your storage resources within your organization. For those of you that have heard me speak before, I can't get a presentation out without talking a little bit about Iscuzzy. I'm a huge Iscuzzy fan, and really truly believe in the technology. So we're going to spend a few minutes talking about some of the benefits of Iscuzzy. What is Iscuzzy? Some of the performance considerations and best practices, things of that nature. And then we're going to dig into it a bit, talking about HA storage and the hypervisor, how they all fit. So what I want to do is bring you through a couple of sample video diagrams that show you sort of how this thing lays out in your environment, and sort of how, sort of under the covers, the high availability storage from StarWind is actually operating, which is a little different than you might think, considering that we're on a Windows platform. A lot of folks assume that we simply go ahead and create a Microsoft or a Windows cluster and cluster our service. We actually do it a little differently and provide a little bit more, or a faster scenario, or a less risky scenario when it comes to actually failing one of your storage nodes by leveraging PathIO. And so obviously we're gonna blow that up a bit and show you how that works, right into some real detail. The second half of the presentation is really, as the slide indicates, putting the theory into practice. So I'm going to actually bring you through a live demo, not only of setting up StarWind, from an HA perspective, how to create a highly available storage target, but also take you over to and show you what it looks like in a VMware environment, and identifying the multiple paths and showing you sort of how that setup looks. Doing it in a Hyper-V environment, so showing you sort of how that looks and how that lays out. And then we'll touch on Zen as well, and I'll show you what the multi-path target looks like in Zen. Zen is actually something that's a little bit trickier to configure, and we've got some documentation that can sort of walk you through that. So for any of you that are working with Zen, know that we support it. Know that we offer the documentation on how to set it up. I just may run out of time in terms of digging into some of the command line pieces to go ahead and get multipath IO configured with Zen. And at the end, we're going to do some Q&A, and the Q&A, as with all of my briefings, is facilitated by the question box there within the GoToWebinar user interface that you've got open to actually be able to see this presentation. If you type your questions in there, I'll answer as many as I can, and any that I don't get to, I'll certainly follow up with you on a one-on-one basis. But by typing the questions in that Q&A portion, it'll record them for me, so that if for some reason I don't get to it, I'll certainly follow up with you one-on-one. And I'll be as candid with you as I can. If for some reason I don't get to your question, there's probably two reasons for it. Either we're running out of time, or I don't legitimately know the answer, in which case I'll follow up with you. I'll do some research and I'll follow up with you, on that, as soon as we jump off the actual presentation itself. So with that said, let me go ahead and jump right in and start the presentation here. Now, I always like to start these talks out with sort of an overview of the traditional Fibre Channel SAN technology. This is a technology that most of us that have worked in IT, over the course of the last 10, 12 years are familiar with. We may not have seen it, we may not have had a chance to work with it, but we're aware of it, and we know what it is. The sort of model of sort of centralizing storage managing storage as a completely separate entity from your applications is not one that's new. It's been around for quite some time. I think what is new is the ability to go ahead and bring this to the small to medium-sized customer at a reasonable price. And I think that's what's sort of evolved over the course of the last 5 or 6 years with Iscuzzy, is bringing a lot of these same concepts to those of us that don't have the very large IT budgets. And so, when we talk about, the traditional Fibre Channel SAN, we're really talking about a very solid technology. This isn't, let's bash Fibre Channel type of scenario here. This is a very, very solid technology, one that has worked, and companies like EMC have brought it to you for years. The problem that we've identified as a company, and I think that we're not sort of unique in this situation, is not everybody can afford it. It could be very, very expensive. Runs across proprietary sort of setups, so proprietary networking, fiber channel host bus adapters going into your application servers, fiber channel switching technologies, fiber channel cabling. So a lot of proprietary, inexpensive type of equipment to set up. So it right away, sort of builds up a barrier to entry for a lot of us. And, before I worked for StarWind, I'd done some time working with various companies as a system administrator and worked a lot in virtualization. So I understand the constraints that a lot of us face when it comes to just not being able to have a blank check when it comes to IT. And so, the problem that a lot of us run into is the cost that's associated with this. And so, we move over to or start talking about the Iscuzzy Sand. Now, this is, admittedly a very rudimentary diagram here, but I use it because I feel like it illustrates the relevant parts without distracting you with some of the sexier things that you can do. Ultimately, when you look at something like this, it looks very similar to the previous diagram. The difference is that we're setting up the shared storage environment using commodity hardware. And so, we're talking about, equipment that you've been using, equipment that you've got in your shop already, stuff that you can go ahead and create a shared storage environment with, and ultimately, set something up that's going to unlock some of those features and allow you to go to, sort of a direct attached environment down to, a sort of more centrally managed storage environment. The other nice part about this is, not only does it lower the bar a little bit from a cost perspective to initially get into something like this, but if you look at the long-term cost of ownership of storage, and we're going to talk a little later about, some of the other benefits of SAN technology and the ability to manage it separately and the economies, the efficiencies rather, that it brings to the table by managing it, as a separate entity. But just focusing on Iscuzzy for a moment, we're really talking about a technology that's going to give you or unlock all those benefits, but really not put you in a situation where you've got to go out and hire somebody with, a storage administrator or somebody with a specialized set of skills. What you're going to see here today is the fact that you can put together something like this based on the knowledge you've already acquired. This is not very difficult to do. It's not very difficult to administer from a long-term perspective. Your cost of ownership from a maintenance perspective in terms of should one of these pieces of equipment fail, you're not talking about breaking the bank to have to go out and replace it. And so, ultimately, there's a lot of benefits that Iscuzzy can bring to the table. As we're going to talk about a little later in the presentation, another fork in the road becomes, Iscuzzy hardware appliances versus Iscuzzy software, where you're able to go ahead and build out your own Iscuzzy Sand versus buying something pre-configured and sort of off the shelf. So with that said, let me go ahead and move this forward. So the next sort of bullet point that we want to talk about, obviously, is the central storage strategy versus the direct attached storage strategy. Now, as I said, I understand that, a lot of you may be looking at this in conjunction with maybe some type of server consolidation through, one of the virtualization vendors, and are looking to, because the server itself now becomes such a critical scenario because it's now, instead of hosting one application, it may be hosting 6 or 7. So a problem with one server be catastrophic. So you're looking to unlock, some of those features, that you need shared storage for, like fault tolerance, high availability, live migration or vMotion, things of that nature. But I'll tell you, to take a step back and think about sort of some of the other benefits that go into SAN implementation or central storage management implementation. The first thing I like to talk to folks about is the efficiencies that you pick up. So, obviously when you're managing storage as a central pool and doling it out as it's needed by creating Iscuzzy targets, you're in a situation now where you don't have to worry about having a bunch of wasted storage dotted throughout your organization in these individual servers. So you're in a situation where you think you're going to need 2 to 4 terabytes in this server, and you go out and, to be safe, you buy 3. You use maybe half of that in the beginning, and the rest of it just sits there and spins. It doesn't do anything. It's consuming power. It's really not helping you out much. But you're going to need it eventually. Whereas the central storage sort of scenario, or managing storage and parsing it out as it's needed, you can sort of combine those storage requirements from those individual servers. Combine it so that you can then buy what you need, dole it out, and then add to it as you need more. And so ultimately you find yourself in a position where you've got a lot more flexibility in terms of the efficiency with which you utilize your storage. Then obviously there's some of the data protection scenarios that go into this. So when we start talking about doing things at a block level, so block level replication, whether it be synchronous or asynchronous, or volume-based snapshots where rather than snapshotting an entire file, we're just snapshotting the block changes that have been made and creating a restore point based on that. So, a lot of opportunities there, and we bring a lot to the table, not so much StarWind or Iscuzzy or Fibre Channel, just the idea of central storage management. And then obviously, clearly some of the other features that become unlocked, right? So some of the other things that the flexibility that you get with shared storage when it comes to a Hyper-V cluster, Exchange, SQL Server clusters, VMware, Zen, those types of resource clusters that you're building. Again, unlocking those features that, quite frankly, a lot of us are a little frightened to move forward without. It's a little scary to put all your eggs in a single basket when it comes to running 5 or 6 virtual machines on a single host without having some automated failover available to you. And obviously for that, you need the shared storage aspect of your IT infrastructure. Now, a lot of you, start to think, okay, well, I'm sold on the central storage piece of it, but, why should I consider Iscuzzy? What is it about Iscuzzy? And really, the title of this slide should be Why Iscuzzy Software. Because I'll tell you, I think that, when we start talking about, as I mentioned earlier, the different options available to you around Iscuzzy, you're talking about 2 basic options that you have. And so you've got to go and buy, something that's prepackaged, pre-configured. There are some options, but not that many, from, one of the hardware vendors that, again, fantastic products, the Left Hands, the EqualLogics, the NetApps, all awesome products. But again, we get into that price point, that lack of flexibility that they may provide you, or you've got a finite number of choices when you choose something like that. It's basically, here are our configurations, here's what they cost. When you use something like StarWind, where you're using Iscuzzy, again, Iscuzzy itself, obviously we touched on it earlier, the ability to go ahead and run on commodity hardware, commodity networking, things like the standard sort of IP networks that you've been using for years, running on top of, the standard server equipment, utilizing standard switching and networking equipment. So nothing proprietary there. All those things really sort of start to inch down that price point in terms of the total cost of implementation. But I think that from the software perspective, we take that and we bring it to the level, because now you're able to go ahead and purchase the software and then ultimately build out the storage box that's going to meet your needs from a performance, but also more importantly from a budgetary standpoint. So, you're not going to be forced into one of 4 configurations. It's going to be, okay, I want to go ahead and buy this server, and it's got, 12 storage bays in it. I'm going to configure it with these types of disk, all, in your control in terms of what you wind up spending. And oh, by the way, 12 months down the road, maybe I'll add an external storage cage to that, or maybe I'll add some additional disk to the internal bays, or maybe I'll add a second server. But the point is I've got those levers to pull on as I'm going through the process of building out my initial storage infrastructure. And so that's why, I think that, Iscuzzy is a real nice fit for a lot of us because of the commodity nature of the hardware, and then obviously the infrastructure that's needed. Then obviously the software Iscuzzy piece, takes that to another level by really giving you the ability to customize this right down to the dollars and cents that you're going to actually spend in terms of getting something like this up and running. Now, I always leave this slide in. I never know sort of who's going to be in the audience. So for those of you that are thinking, Bob, we don't need to know what Iscuzzy is, we already know, apologies. But I do want to spend just a few minutes on this. Iscuzzy obviously is the traditional SCSI commands that are going to be encapsulated and transmitted via TCP/IP from an initiator down to a storage box, running, or presenting Iscuzzy targets. You have the option, obviously, of, from the initiator side of using software-based initiators or hardware-based initiators. And obviously this is going to interact directly with the TCP/IP stack on these boxes. The Iscuzzy service, runs on the storage servers, so that's going to present the either physical disk or virtual storage targets that you may choose to create, and we'll talk a little bit about the differences in those two in just a few minutes. And then obviously the commodity hardware aspect of it, and I know this is redundant, but I feel like it's a point that's worth making. We're talking about the traditional IP networks, off-the-shelf server equipment. Without a large upfront cost, we're getting you into a shared storage environment, and that is Iscuzzy in general. The other piece that I like to talk to folks about a lot when we talk about IP networks and the networking that you're doing, anyone that's looking at 10 gig networking and 10 gig and looking at what do I got to do, or how do I cost justify moving into something like this? This is just another point to consider. So now, as you're sort of moved from a gigabit backbone to a 10 gigabit backbone, you're talking about being able to add another value point to that investment that you may make in 10 gig networking by extending that to your Iscuzzy or your shared storage environment. Now, obviously, some of the benefits, when we talk about familiar networking standards, and I just, I don't think that you can say enough about this. I know that, at least in my experience or my tenure here with StarWind and in my experience in general, working for, the last 15 years in IT, there's a lot of folks that become very intimidated by that proprietary, equipment and having to learn something new and have it to speed, or, maybe it's a situation where now your company's got to build in another salary into the budget because they've got to go out and they've got to hire somebody that knows how to do this stuff. Those familiar networking standards make it very simple for, myself or any other sort of off the street IT guy that's got a real good solid knowledge of how networking works and how the end user applications work. It's going to be pretty easy to set something like this up. Some of the data protection features, which we're going to focus today on high availability, but also the ability to do distance replication or DR, by replicating data across a long thin pipe down to a DR site, or being able to do point-in-time snapshots and be able to do file-level recoveries, all at the block level, so all at the storage level, eliminating your need to try and pull that off with your backup software or something along those lines. Eliminating the cost of overhead. Again, the proprietary stuff, you have to consider not only is the bar raised for the initial investment, but also you have to look at, what's it going to cost down the road as equipment breaks or as equipment is retired and needs to be replaced. And then obviously for those of you that are already running Fibre Channel, again, One of the things that I preach, for those that come to us and say, well, gee, I'm already running Fibre Channel, let's talk about a tiered storage strategy. Let's talk about, you've already made the investment in, a really rock solid piece of equipment. But let's talk about, are there things on there that don't need to be? Rather than make more of an investment or dump additional dollars into something that, maybe you're tying up space with, that stuff doesn't need to be there. You offload it to, something else, whether it be Iscuzzy or NAS or something along those lines. So those types of strategies are often discussed here in this office with customers and prospects who are sort of maybe on the higher end and are already running some Fibre Channel SAN equipment. Now, one of the things that always does come to mind and is always a concern for most folks is the performance best practices and how is this going to perform in my environment. And I think that there are some basic principles that you want to follow when setting something like this up. So for any of you that are either considering doing something like this, maybe in the next 6 months, or are kicking the tires on some of this technology, or maybe you're actively evaluating, or perhaps you recently purchased. I think the key here is going to be, in terms of networking, network isolation. And so, I talk to customers all the time about the importance of sort of segmenting off this traffic and making sure that, on the initiator side, you've got dedicated NICs. Your storage box is properly loaded down with, enough channels or enough paths to the storage, not only to create high availability, but to be able to also go through the process of eliminating a single point of failure, but also be able to go through the process of load balancing across multiple NICs to be able to make sure that you get the most when it comes to performance. Network optimization, this is, again, pretty much a no-brainer when it comes to things like jumbo frames and optimizing the DIP window size, some small registry tweaks you can make to make sure you're squeezing the most out of the networking that you've got in place. Then, what it comes down to, and a lot of performance problems that I actually wind up coming in and diagnosing for folks, it's not necessarily network related. Most customers, their disk subsystem is the slowest part of the equation. And if that disk subsystem is not configured correctly, it's going to cause performance problems all the way down the line. And so, whether you're setting up, a high availability storage solution between two Iscuzzy targets, or if you've got a standalone box where you're just creating maybe some snapshot enable volumes, this RAID configuration, the configuration of the physical storage in that box can really be the undoing of an implementation from a performance perspective. Things like making the right choices around the type of disk you're going to use. You can't buy SATA drives and expect SAS performance. And so you have to make sure that you're pragmatic when you're making those choices up front, and we're certainly here to help you do that. And then looking at things like I/O patterns, and this is a common mistake that a lot of folks make, is that they'll go ahead and they'll have, because they're virtualizing the storage, they can create a virtual storage repository that's going to service a data store that may be a more sequential type of I/O pattern, like a data warehouse. And then on the same set of spindles, they'll create a virtual storage repository that's going to service a highly transactional database with a lot of random I/O. Those two obviously being at odds is going to create a pretty large bottleneck in the disk subsystem. And so it's things like that that you want to make sure you think through when you're setting up these things. And then obviously one of the other pieces of advice that I give everybody is monitor. Keep an eye on the disk performance, things like disk queue length. That can quickly be a sign of a bottleneck, getting out in front of that fast enough. And there are a lot of great free tools out there that will help you do that. And obviously, if you're interested, just ping me a question on that, and I'll make sure I follow up with a list of sort of free tools that you can use to monitor your sandboxes. Now, the other thing that we want to talk about in today's demo is going to be focused, mainly on high availability storage, but I do like to touch on some of these other items. I know I talked about full replication, so that from an asynchronous or an active-passive scenario, you're going to be able to go ahead and set up your data so that you've got an active storage controller to which all of your initiators will connect, and that data is asynchronously replicated down to a passive storage controller. I talked a little bit about point-in-time snapshots. So that is the ability to go ahead and at a set interval, whether it be hourly or 3 times a day, grab the file or the block level changes, rather, that have been made to that volume. We allow you to go ahead and either roll those volumes back to a point in time, or you can take our snapshots and mount them as read-only targets and extract data from them, which gives you the ability to go ahead and do things like a file-level recovery in the event that you have a file go bad or is deleted. Storage security, things like CHAP authentication, which is going to control who's able to control unauthorized access to specific storage devices through the use of usernames and passwords. IPsec, which is going to actually encrypt the communication between the storage server and the initiator. And then things like LUN masking, which will just basically say, okay, this LUN can be exposed to these 3 application servers, and that's it. And then high availability, obviously, which is what we're going to get into here next. Now, I always like to start off the high availability discussion by sort of giving you an overview of what it would look like in the wild. Now, obviously, when we talk a little bit about use or in practice type of scenarios, I have got to pick one here. So I chose Hyper-V in this case. But quite frankly, guys, the diagram looks, incredibly similar under, ESX or under Zen as well. So, just to give you a flavor for that. So, obviously, when you set something like this up with a high availability storage target, you're first off, if we work right to left here, we're talking about the 2 StarWind storage nodes. So obviously you're going to want to have node 1 and node 2 set up and configured running StarWind with the physical storage platforms configured. So you want to make sure you've got that ready to go. The other piece here, the blue networking connection, in this case I represented it as a crossover cable, a simple crossover cable, but whenever you do StarWind high availability, it does require a synchronization channel exist between the 2 boxes. And obviously, the nature of multipath I/O, it's going to present 2 active paths or 2 available paths to the storage. And then a load balancing policy on the initiator side is going to determine which blocks get written or which blocks get sent down which path. And so ultimately, the initiator will make the choice, and if it chooses to write a particular block to node 1, that block needs to be replicated down to node 2. Same if it decides to write a particular block to node 2, it needs to be replicated up to node 1. So that synchronization channel is a critical component of the HA set. The other piece here, obviously, in red, I've got, and it may be a little tough to see, the actual storage network. And so I've got a network, some networking dedicated to the storage running through, in this case, a single gigabit switch. Now, depending on budgets and criticality of these applications, some customers will choose to put, will choose to take multipath to the next level and actually run multiple NICs off of both the initiator and the storage node and run them through different switches, so they've got redundant switch technology. That's also an option that's supported here. It just depends on, how far you want to take it. But obviously there's a separate network set up there for your storage, and so that's obviously connecting each Hyper-V node to the individual storage or HA nodes on the StarWind side of things. And then obviously your typical cluster type of networking, so a heartbeat network along with a VM network that's going to go ahead and connect your virtual machines to the user environment or the user community out on the corporate LAN. And so ultimately each one of these Hyper-V nodes in this case will be configured with the MPIO driver. And then ultimately, as you're going to see as part of the live demo, we're going to present 2 separate targets. And MPIO, because they're going to be presented with the same unique ID or same serial ID, it will combine them and present them as one physical disk or one unified storage disk to the operating system on that particular node. And so if you connect, those high availability devices to all the nodes in your cluster, you suddenly now have a piece of clustered storage that's not only going to provide your VMs with high availability from an application or hypervisor perspective, but also from a storage perspective. You're going to be in a situation where if you were to lose one of these storage nodes, you're no longer going to be in a situation where you're going to lose connectivity to your storage. So you're essentially eliminating that single point of failure and spreading the risk out across two physical assets. Rather than, saying I'm going to take one box and I'm going to stick dual controllers, dual power supplies, the way we've chosen to do this is to spread the risk out across two physical assets instead of a single physical asset. Now, taking a closer look at MPIO, obviously, we start to get a clearer picture of what's going on behind the scenes. As you'll see during the demo, we're going to be talking about having multiple active paths of the storage with a load balancing policy set at the initiator side. So, the initiator is going to decide, whether it's round robin or fixed path or least queue link depth. It's really going to depend on how you want to set that up. And each situation can be slightly different in terms of, how to squeeze the most performance out of something like this. And so, if you've got questions on configuration or whatnot, don't be shy to go ahead and type that in there, and I'll make sure I follow up with you on that as well. As you can see here, we're talking about a scenario where, we're going to have a couple of, active paths to the same piece of storage, one traveling to node 1, one traveling to node 2, station in between. What this is essentially going to do is it's going to allow me to eliminate one of these nodes, and it could be something as benign as I've got to do a Windows update, so I've got to reboot one of these things, without losing connectivity to my storage at the initiator side. What will happen is if one of these nodes fails, when it comes back online, I simply kick off a background synchronization. That will go ahead and tell this node here, the one that's recently failed, to go over to node 2 and request any data that it's missing. So it knows when it went down. It'll say, give me all the data since this particular point in time. We call this a fast synchronization. And it will go ahead and bring this node back into sync. And then ultimately, once that's done, that second pass of the storage will reopen for business. And then it'll go ahead and start accepting I/O again. So, I think the scenario here is really in a position where, again, you eliminate that single point of failure when it comes to going through the process of configuring this. So with that said, let me take you over to sort of the live demo portion of this now, and I want to start off with the actual StarWind setup here. And so, in talking a little bit about sort of how this works, and we've talked a lot about the process of going through and actually configuring and having all these choices to configure your sandbox. What I hear is I've gone ahead and done all that already. So I've got a couple of storage boxes. I've gone ahead and configured the drives. I've installed StarWind here, and I'm essentially managing two boxes here from the StarWind user interface. I've got a 151 box and a .202 box that I'm managing here. Now, what I'm going to be able to do here is go through the process of actually creating a high availability storage target by just creating it on one of these boxes. It'll ask me for the partner, as you'll see, and it will ultimately create my target set. So let me go ahead and start off by actually creating one of those. So I'm going to go ahead and select this as my home server, my primary server here, and I'm going to click on the Add a Target button. And we'll call this and we'll go ahead and move forward here. Now, obviously, this is going to be a hard disk-based target, so I'm going to leave the hard disk button checked. And then this is actually going to be one of our advanced virtual devices. And what we're doing here essentially is we're creating, as you're going to see here in just a moment, two virtual storage devices, one on server A, one on server B, that are going to act in concert as a high availability device. And so, as you can see here, some of the features that I talked about earlier in the presentation, the ability to do an asynchronously replicated or active passive storage array, a snapshot-enabled device, and then finally our high availability device here. Now, the first thing it wants to know is what's the partner, where's my partner server in all this? So I'm going to go ahead and tell it where the partner server is and the credentials for that service. And it goes out real quick and makes sure that the service is there. It is indeed running. It is indeed licensed. And then it's going to tell me here that I'm going to create a second target. So if you remember, I gave my target a name in the first step. It's now going to go ahead and create the target, and it's going to add the word partner to the end of it. That's a very simple way to be able to identify that. Next, I need to go through the process of actually creating these virtual storage devices and assigning them to physical storage asset in each one of these boxes. And so in this case here, this is the current server. This is the server that I'm operating on or creating this device on. And so I can come here and actually choose. These are all the physical volumes that I've presented to Windows. I can choose one of these, and we'll call this. And I'm going to do the same thing on the partner server, which is that second server. And it'll remote me into the file browser there. And I'll choose a storage platform. And we'll go ahead and create that. And I've checked the Create New box here because I want to create 2 new virtual storage repositories. And I'm just going to, for the sake of the demo, leave it at 100 megabytes. Now, the next step in the process is for me to go through and actually identify my synchronization channel. Now, to take a second to talk a little bit about the networking, and I touched on this a little earlier, with the high availability scenario, what most of the time what I'm going to suggest to folks is they set up a 5-port configuration on the storage box. And so you're looking at 2 ports that are going to be assigned and made available to accept Iscuzzy traffic. You don't have to team them because MPIO will identify those paths, so ultimately you're going to wind up with, for your HA device, 4 active paths to the storage rather than just 2. But 2 ports for Iscuzzy, 2 ports that you will want to team for your synchronization channel. And to the degree that you can, I like to tell folks if the servers are in close proximity, to simply go ahead and team these interfaces and plug them in through a crossover cable. This eliminates the possibility that the rebooting of a router or something like that, or a switch, is going to create a problem with that server synchronization. But ultimately, what you want to do is you want to also have some redundancy there to avoid any split brain type of scenarios. And then the last port, obviously, I like to tell people use that to plug it into a management network or have a spare port just in case you need one. But in this case here on this screen, you definitely want to go ahead and select that appropriate path that you're going to use, or that appropriate IP address that you're going to use to go through the process of synchronizing, and gone ahead and made that choice. And then lastly, it's simply a matter of how do I want to initialize these. Now, I could clear the virtual disks, which will zero out the files. I could synchronize in one direction or another, or I could simply not synchronize, which would just mount the 2 of them on both sides. And where they're blank, they'll automatically be in sync anyway. I just chose to zero them out, and it will go through and create these for me. And it's created the target here, and then it'll come down here and create it here for me as well. And you can see this one here has zeroed out, and it is now reporting as synchronized and ready for use. And this side here will go ahead and zero out as well. And now that's zeroed out, and that's ready for use. So now I've essentially created my HA set. So the next step for me is to go ahead and link this up to my initiator side. In this case here, my first example, I'll go ahead and use VMware. I've got a small VMware setup here, a small lab setup here, and I've already got some targets that have been pre-created, and I'm going to walk you through these. But ultimately, what we're looking at here is a very, very simple setup here, in that all you've got to do once you've prepped your ESX host for Iscuzzy, then it's a simple matter of coming down to the storage adapters. You've already created your VM kernel port, etc. You're coming down here, and in the properties section of the Iscuzzy initiator for VMware, you're simply plugging in the IP addresses that correspond to the boxes that contain your high availability storage devices. Now, what you want to do is if you've got, 2 NICs in each one, you want to go ahead and plug in. In this case here, I've got 2 NICs in one box and only 1 NIC in the other. They just wouldn't give me the lab budget to get that 4th NIC. But you'd want to put, all 4 NICs, all 4 IP addresses in here so that you get 4 active paths, 2 on box A and 2 on box B. And it will go out and it will discover those storage devices. And as you can see here, I've got the devices. So I've got, 18 devices with 39 paths to the storage. And so if I look here, once I've connected that up, I'm then in a position where I can go ahead and create my VMFS data stores. And to get a sense of what one of those looks like once it's been created, it's very, very straightforward. Once you've created this thing, it's essentially just going to go ahead and present you with a scenario where now you've got that 3 active paths in this case. These 2 here are in storage node A. This one here is in storage node B. And as you can see here, my path selection policy or my load balancing policy is set here. And so I've got fixed here, and so this is really what it's going to do. It's going to use these. It's going to primarily use this particular path to the storage. It walks down this path. The synchronization channel that's set up will make sure that those blocks are synchronized over to the second box. I could use something like round robin, where it's going to load balance across the 2 if I wanted to. So there's a lot of different options here in terms of how that's going to be set up. But the net here is that if I were to lose one of my StarWind boxes, reboot it because of Windows updates, it catches on fire, the intern spilled coffee on it, the RAID controller died, the disks died, whatever the case might be, I'll continue to simply, there's no waiting for failover. There's no, waiting for a service to spin up on a second box. It's basically going to continue down the other active paths to its storage. And so you will not be in a situation where you're going to lose, or anything's going to time out on you from an I/O perspective. And so this is really where this comes into play and really, giving you that fault tolerance, because clearly, I've already got it here. I've got a 3-node resource cluster up here. I've got HA enabled here. So if one of these hosts dies, all my virtual machines are going to be spread out across the remaining 2 hosts. My problem is, what happens if one of my storage nodes dies? And now I've got that covered in the event that that happens. Now, it looks very similar, from a Hyper-V perspective. And so, as I come back over here and I take a look at a Hyper-V cluster that I've got set up here. And again, I'm back-ending this with high availability shared storage. Now, a couple things to note. One, you do have to install the MPIO rule on this, or feature, which is not a big deal. And then ultimately, we do also, it's worth noting, we support the clustered shared volume technology. As you can see here, I've got some clustered shared volumes here that have been set up. But from that perspective, all you've got to do, once you've installed the MPIO rule, you've come in here to the administrative tools in MPIO. You've gone through and, under the Discover Multiple Paths. Now, this is grayed out because I've already activated it. But once you initially connect to your first multipath storage device, you want to come into this MPIO console, and this box will be lit up. You want to check it, click Add. It'll prompt you to reboot, so make sure you're ready for that when you install the multipath for Iscuzzy. It's going to force you to reboot the node. Once it comes back up, you simply fire up the Microsoft Iscuzzy initiator, as you can see here, and then ultimately what you're going to be looking at is, plugging in the IP addresses, again, that are associated with your storage boxes, and so you'll plug those in, and then ultimately that'll present the targets. Now, where it's a little different than VMware is that you actually have to physically connect to both targets here. And so in this case here, I've got a quorum partner, and down here, so it's quorum D partner, and down here a little further, I've got a quorum D. And so I would connect to both of these, and when I connect, just simply tick off the enable multipath there. And essentially what you're going to wind up with is, let me get back to that. I'll do it from here. Here we go. If I look at devices and I look at the multipath, here are all the different connections I've got to this storage. And if we look here at the details, There's a 202 connection, and then there's a .80 connection. There's multiple paths to that storage. And again, similar to VMware, I'm setting my load balance policy at the initiator side. So I'm going to decide, how this is going to be spread out. Now, of course, again, the same principles apply. If I were to lose one of these storage boxes, if I had to bring it down for any reason, it's very easy for me to bring that box down and then bring a node back online, do a fast synchronization. And so let me just sort of show you where you do that here. And so if I were to bring one of these nodes offline, when I brought it back online, there'd be a little warning sign there. And basically, when I click on it, and over here, there'd be a little red triangle. So I'd see a warning, and then it would tell me this is out of sync. It would also tell me here which node is out of sync. So it would tell me that the current server, the current one that I'm checked on, is either synchronized or not synchronized. If it was out of sync, I would simply kick off a fast sync. And again, that would go through that process of going over, pulling the data from, the point in time where it went down and bring it back into sync, and then open that second path up. I won't have to reconnect it manually at the initiator side. It will reconnect on its own. But ultimately, like I say, I'm spreading that risk out across two storage boxes and really giving myself a similar scenario that I am here with this two-node Hyper-V cluster, where essentially if one of these nodes were to go down, I'm now mirroring that level of high availability at the storage level now as well. And then just to touch on it real quick, because I know that it's a little bit more involved, especially with the sort of the way you've got to connect our stuff to Zen. But obviously, from a Zen perspective, some of the command line stuff, we can get you down to the point where it's a similar scenario. And as you can see here, I've got a virtual machine hosted on an Iscuzzy store with two paths active. So I've got two active paths to this storage. So I've got, box A and box B. And so, again, it's a similar scenario. It's set up in an active configuration. Again, eliminating the chance that you'll run into an I/O timeout should one of the boxes fail. And really giving you or matching that level of high availability that you've implemented at the application or the hypervisor level, it matches that at the storage level. So again, very easy way to go through it and sort of put something like that together. So with that said, that was kind of my live demo portion of today's sort of program. What I'm going to do now is I'm going to go ahead and start the process of answering some questions, and I'll see if we've got any in here to start. And if you do have questions, die about sort of plugging them right in straight away. I'm certainly, like I said, I'll get to as many of them as I can. And as being as candid with you as I can, if I don't get to your question, I probably didn't have the answer at the tip of my tongue, but I'll certainly research it and get back to you. So let's see here. Can you please mention some of the free monitoring tools by name? Absolutely. The one tool that comes to mind here, guys, and I know a couple of you have requested this. The one tool that comes to mind that I use quite a bit is a product from Quest Software called Spotlight on Windows. Spotlight on Windows does a really nice job of giving you a graphical interface. It sets a baseline for your storage devices. It allows you to set up alarms on different counters. So, if you want to monitor disk queue lengths, if you want to monitor things like memory or CPU utilization on those boxes, you want to monitor the networking, you can certainly do that. There's also a network monitoring tool out there that is free as well, and I'm embarrassed to say the name. It's called the Dude. Do a Google search for it. Another very, very interesting tool to sort of do some network monitoring on, so that you can monitor the Iscuzzy network as well. Let me pick through here and see if I can find a couple of questions here that seem exciting. Let's see, how much disk overhead is added by the syncing? Matt, there is some. Now, I'll tell you, when you synchronize or anytime you have an HA set up, one of the challenges is maintaining a level of performance. So, really putting our cards on the table from the StarWind perspective, we've made sure that, or we've tried to sort of direct folks into making sure that they select the appropriate disk setups to make sure that that is a minimal impact. There is going to be some overhead. You are going to notice an overall sort of a small performance hit if you were to compare it to, say, a standalone target, but it's sort of the trade-off that you make for high availability. Now, one of the things that StarWind is working on, and you're going to see it from us here in the coming, say, 2 months tops, I mean, we're just getting ready to go to beta on it, is the implementation. Most of our devices, we give you the ability to create an I/O cache using physical RAM in your storage box. So the only device we haven't done it for yet is the HA device because it's a little trickier. And so we're sorting that out and hope to have that put in place here a little later this year. And that will, if it's implemented correctly, will sort out a lot of, or smooth out a lot of the overhead that's associated with the performance hit that you take, because of the synchronization, because of, the multiple confirmations that are needed in order to commit to a piece of I/O. Let's see here. Let's see what we've got here for questions. Is there any reason not to create a StarWind Iscuzzy Sand using storage from a VM? We currently do not have a big demand for the host server. Okay, yeah. So basically what I sense you're asking is it possible to go in and actually set it up so that you're creating an Iscuzzy target? You basically maybe create a virtual machine, install StarWind, and then maybe create like a raw disk mapping from a local data store to that and serve it up that way. Absolutely can be done. We've got a lot of customers that are doing that. Obviously, a lot of the same principles are going to apply. One, you're going to want to keep an eye on the resource utilization there, and make sure that that's going to be a virtual machine that's going to have a little bit of a footprint. But also from a networking perspective, you're going to want to make sure you do that properly as well. But certainly, it's a supported configuration. It's something that we've seen done in the past. I've worked with a number of customers that have done it both in a VMware and a Hyper-V environment where they've actually taken and passed through, created an AA set from the local storage in these virtualization hosts or these virtual hosts, and ultimately it's worked great. So certainly something that you can do. Let's see here. Plug in the physical. Is it possible to replicate such storage to an Iscuzzy storage like StarWind? So the question I have here is I've got 2-node Win 2008R2 cluster plugged into physical, looks like an MD3000. Is it possible to replicate such storage to an Iscuzzy target like StarWind? Marcos, I'll actually email you offline. I think that one of the things you may be interested in talking to me a little bit more about is actually a new product from StarWind. We've got a separate sort of storage management product that's going to be coming out where you'll be able to actually replicate between a third-party SAN and a StarWind SAN. So I'll reach out to you on that. That's a great question. Let's see here. If one of the storage nodes hiccups or freezes for a minute, I am assuming another node would take over. Assuming this is true, does the data replicate back to the hung node? That's a great question. And so in your scenario, and under the current code set, we currently support just 2 storage nodes at this point. So if one of the storage nodes were to freeze or were to hiccup, it would create, basically an Iscuzzy timeout on that side. So basically it would stop accepting transactions. The initiator side would see that. It would kill that path to the storage. When that came back on, at that point, that node would be marked out of sync. And so you'd have to go into the user interface and actually synchronize that node again. That would happen in the background. You wouldn't lose any connectivity to the storage, but under the current code set, you would still have to manually kick off that synchronization. What's coming from us in the next release is the auto-synchronization feature. So if that indeed does happen and it's long enough to knock the node offline, when it comes back, it will go ahead and auto-sync itself up. So, but again, you wouldn't lose any connectivity to your storage. Let's see here. Are you working on a VDS driver for the SCVMM? Yes. So Virtual Machine Manager for Microsoft. We are. I don't know exactly, or I can't say exactly when it will be ready. I do know that this is something that we're looking at, and sort of doing more than looking at. Really, sort of started speccing it out and doing some work on it, working with Microsoft. So it is something you can expect from us. Like I said, I think I'd be doing you a disservice by setting a date to it, off the top of my head. But certainly, I'll look into it and follow up with you directly on that without a problem. Let's see here. Oh, I got a request to repeat the tools that I use for monitoring. And so the main tool that I recommend is a tool from Quest Software called Spotlight on Windows. That's the main tool that you can use to go ahead and monitor that StarWind sandbox. It'll do everything from CPU, memory, networking. It'll monitor things like disk queue length. It's got a very nice graphical user interface. It can be set up to send out alarms and alerts, if something were to happen. And then the other was a network monitoring tool called the Dude. Kind of a weird name, but it's a nice little tool and it's free. Both of those tools are absolutely free, so certainly something that you can sort of look into. Let's see here. What should the cluster size be on disk? That really depends on the applications and the type of setup that you've got in terms of a set. That's something that Max, I can give you a buzz this afternoon. I've got your contact information. I'll give you a ring, but we can talk about that. It really depends on the type of application, the RAID set. So there are a couple of different factors. The stripes that you're using, say, on a RAID 5 could potentially impact the cluster size you want to use on a disk and really have an adverse effect on the performance if it's not set up correctly. Let's see here. Who can I call to help me further with best practices with StarWind? Doug, you can give me a call. If you go ahead and check out the contact information I've got up there, 617-449-7717. I'm at extension 104, so feel free to go ahead and give me a ring directly. I'm certainly happy to help. With that said, there's a ton of questions that I did not get to, but I do need to sort of wrap up and keeping this to the hour. However, those questions that did get asked, I've got a recording of them here, and once you've typed them in, I've got them. I'm going to go through the spreadsheet, and between now and, say, this time tomorrow, I'm going to reach out to each one of you and make sure I get you an answer to your question, or at least let you know that I'm working on an answer for you if I don't know it. You'll also be getting an email from me thanking you for coming to the event. If for some reason you want to set up a one-on-one, you want to talk about your situation, you want to talk about how this might look, or you want to bounce some ideas off me for hardware or get some recommendations, don't be afraid to reply to that email. It may take me a few hours to get back to you, but I'll certainly get back to each and every one of you. I really appreciate you taking the time to look at sort of our technology and consider our technology. We're well aware of all the choices that you have out there in the market, and so we're very excited that each and every one of you has decided to come and spend an hour with me and sort of kick around some of this stuff. So don't be shy about responding to that email. As I said, you'll get a scenario where I'll go ahead and respond to each one of these questions that's been typed in. You'll also get an email from me probably in the next 48 hours. I've actually recorded this session as well, so we'll make sure you get a link to where you can download the recording if you're interested in seeing more of it. I really do appreciate everybody's time. Thanks for coming out. We do a number of these types of events, so keep an eye on our events page. For sort of the next event that's coming in the series. And like I said, don't be shy about reaching out to me directly with any questions that maybe just can't wait. I appreciate your time, and we'll talk to everyone real soon. Thank you.